Right. A projectile is fired with initial speed 15I and 40J. So does anybody know what 15I and 40J means? The first question I'm going to ask you. What does that mean? Anybody find this? Okay. What it means is 15 horizontal and 40 vertical. So every second it travels 15 meters across and 40 meters upwards. So what direction are we talking here? We're talking that it gets fired up this way, aren't we? Agreed? And yeah, so that's the first thing. What happens if let's say an archer fires an arrow? What will happen to the arrow? What happens? It goes up and then it comes back down again, okay? And what this is referred to is the archer's range, okay? So the archer's range is the yellow distance. How far can I hit a target? This blue distance here, anybody, what do you think that's called? Max height, greatest height, yeah? These graphs are symmetrical. You're not taking in wind resistance into account, okay? So the time it takes to get up is the same as the time it takes to get down. Symmetrical. Cool with that? Okay, now, you're going to introduce, every time you do a projectiles question, there is 4 equations. Ready? Let's begin. We start off with Vx. Vx is quite simply your speed in the x direction. What do you think the answer is? The speed in the x direction. Anybody have an idea? 15. Vy, 40. Now hold it there for a second. Does it stay at 40? Why? It's acting against, it's in the y direction, and the y direction acts against gravity. Gravity is an issue. Is that all right? So we're going to use V equals U plus AT, and what we're going to say is it's 40 minus GT, or if you want, 9.8 T. Is that all right, you guys? Yeah, 9.8 T. Okay, let's go to Sx. How do you calculate how much distance you traveled in this direction? Why don't we use the formula ut plus a half at squared? Okay. What's u in the x direction? What's your speed in the x direction? 15 multiplied by time plus a half. What's your acceleration in the x direction? Is there any? Gravity only acts directly down, so there is no acceleration. So therefore the answer is quite literally 15 turns to 15 t, because distance equals speed multiplied by time when there's no acceleration involved. Okay with that? Now what about Sy, guys? Sy, what do we think here? Use ut plus a half at squared. What do we think? 40t, yeah. Half gravity divided by so 9.8 divided by 2, isn't it? Because it's negative gravity. So a half 9.8 times t squared. You cool with that? What is a half 9.8? Really? There we go. Bit of life. 4.9 t squared. You cool with that? These are your 4 equations of doom. Agreed? Now, it wants the time to reach the maximum height. There is a criteria for maximum height. If this is still 40, what would happen? You would never, ever, ever fall. When do you start falling? Yeah. So your greatest height is when it reaches 0. So your criteria for greatest height is Vy equals 0, because you're no longer rising anymore. So that's it. So you get your Vy equation and you put it equal to 0. Ever see this one here? I'm just going to say it's 9.8t equals 40. And somebody do 40 divided by 9.8 for me. Keep as a fraction. Fractions are better. Here we go. Keep as a fraction. 249. That's my boy. 49. Sorry. We go. That's the time to reach your maximum height. Now, it wants me to calculate the maximum height. Actually wants me to figure out what this thing is. What formula should I use? Should I use Vx? The velocity is 15 in the x direction? No. Should I use Vy? It wants the distance. And height is a distance. Vy is a velocity. So not that one. Should I use the distance in the x direction? Sx? No. Should I use the distance in the y direction? That's your one. We have to use Vy. Sy gives us the distance in the y direction. So what do we do now, guys? Anyone tell me? Sub in the t, yeah. Somebody on the calculator with that for me? So it's going to be 40 times 200 over 49 minus 4.9 by 200 over 49 squared. You guys are going to 4,000 over 49 meters, yeah? Is that okay? You can give it to me in decimal if you want as well. Go on. 81.63 meters. So it rises 81.63 meters into the air. We okay with that? Okay. Now, next thing. It wants what's called the range. Everybody see the range? Okay. So the range. How are we going to do this? The range. Okay. Now, there's two ways you can do it. The first way you can do it is you can say that, well, when you hit the ground, what do you notice? When you hit the ground, the SY value is 0, because you're on the ground level again, so your SY value is 0, isn't it? So you go to your SY equation, and here it is here, and you replace SY with 0, yeah? And then what happens? Factorize out t. So can I put the equal 0 on either side, can't I? So factorize out t, and you get 40 minus 4.9t is, so there's two answers. The first answer is t equals 0. Why is t equals to 0 an answer? Because you start off on 0 ground. And then the next answer is 40 minus 4.9t equals 0. 4.9t is equal to 40. Somebody do 40 divided by 4.9? 400 over 49. Did anybody have a shortcut rather than doing that? What's the shortcut? What you know is about the time for the greatest height compared to the time for the greatest distance. Yeah, you doubled it because it's symmetrical, wasn't it? So we could have just doubled it. But ultimately, you need to know both methods. So you have to be aware of both methods. Is that okay? Now, what are we after now? We're after what's called the range. What direction is the range in? So what formula would be a good idea? 15 multiplied by your time. So get your time and just multiply by 15 and you'll get your range. Anybody? 6,000 over 49. 6,000 over 49. cool with that? Okay. What's asking me to do next is, it's asking me to close that. Okay. What's asking me to do next is the following, all right? It's asking me to plot an accurate diagram of the path of the flight. See the graph I already drew? It's going to look roughly like that, but it's not going to be quite the same, all right? So here's what I'm looking to do. You ready for this? Do you see the two speed formulas? Oh, sorry, the two distance formulas. You see these two formulas here? Okay. So I want you guys to take out your table function in your calculator. Okay, and here's what I want you to do. Do you all know how to use the table function? So you have two functions, don't you? F of x and g of x. Right, perfect. Right, so here's what I want you to do. And just so we know how far to go. How long were we in the air again? Was it 400 over 49, was it? Yeah. What is 400 over 49 in decimals? How long were we in the air? It's known as the time of flight. So can you just give me 400 over 49 just as a rough number? What do you reckon it is? So 9 seconds should cover us. 10 seconds will definitely cover us, won't it? Less than 10 seconds. So here's what I want us to do. Okay, where is my formula? So what I'm getting everybody in the class to do currently is the following. I'm going to grab this here, I'm going to cut it, I'm going to move it over to my graph, I'm going to paste it. And here's what you guys are going to do for me right now. You guys are going to change f of x into 15x. You're going to change g of x into 40x minus 4.9x squared. You're going to start at 0. You're going to end at 10. And at t equals 10, I mean. And then you're going to do a step of 1. And you're going to get me both tables. Does anybody not know how to do that? I'm liking this. Now, here we go. Somebody's going to sort me out with the table now. So we're going to do SX, SY, and time. So let's go make myself a little table here. So, okay. And here we go. So this is my t value, my SX value, and my SY value. All right, and I'm going from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 should do it. All right, what's your SX? 0, 0. Yeah. 15 what? 15. Am I right? I just count up in 15s here. Yeah. Yeah, so that makes my life easy, doesn't it? What's the last one? 135? Yeah. Okay, and over here, SY? That's 9. 9? Yeah. First, next one? 116. 9, and then 116? Yeah. That's not right. Yeah. Go again. 25.1. Next one. 60 points. Or next one. Yeah. Next one. Next one. See the way I saw it reach its greatest height already? It's on its way down, isn't it? Next one. Yeah. 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 I'm not really drawing that, are we? Okay. Now, I have my axis here, don't I? Okay. And I'll make every 2 blocks worth a second. How high do I have to go? All the way to 80, is it? Should probably stretch this as best I can. So I might make each block worth 5. What's that? 60. Just about have enough to get to 80, don't I? And then That pretty much gets me to, is that right? 65. Oh, each one's worth 4 there, isn't it? Oh, I got mixed up. Sorry. Meant to be going up in 4s, not 5s. So that's 60, 80, and I have enough. Ready? Okay, so 0, 0, yeah? Next one. So 1, oh, sorry. Ugh. Huh? Yeah, do it, do. Sorry. Uh, distance, time. Yeah, you're right. Sorry, I was never meant to do time, was I? I was actually just meant to do. I was meant to just do distance. Yeah, I got mixed up there, so I'm actually doing distance. So just go for 15s, will I? Yeah, the 15 sort of makes it handy. All right, let's go again. 0, 0, yeah? 15 and what? So 25, 30, 35, yeah. Next one. 60.4, so just a smidge above 60, yeah? After that, 45 ants. So just go for 75 there, yeah. 60 ants. So just a smidge over 81, yeah. For 75, yeah. Okay. 90 ants. Less than 65, yeah. Next one. 9.9, this is very similar to 40, isn't it? 120 and 6.4 is a little bit above 5, and then done. And look, there's your graph, isn't it? Now I might get a bit wonky on this because it's very hard to draw these on this drawing apparatus I have going on here. Might have lost a bit of marks. Where do you think? Bit wonky there, wasn't it? I got a bit there. Oh god. Yeah, there you go. You get the gist, don't you? That's the curve we're expecting, wasn't it? Should label your axis. That's SY in meters, and that's SX in meters as well. Go. Okay. Now what's the last thing it wants from me? Find the speed of the particle 2 seconds after takeoff. Okay, well, this is interesting. Speed. I'll give you a classic example. If I was traveling at 3i plus 4j, can anybody tell me what speed I'm going? That's my velocity. But what's actually my speed? You have to use Pythagoras' theorem, and you find out that the hypotenuse is 5. So your speed is actually 5. Everybody cool with that? So here's what we're going to do. What do we know about the x speed? The x speed is always going to be 15. But what do we have to do with the y speed? Can anybody tell me? Replace t with what time? 2. T with 2, yeah? And what's 40 take away 19.6? 20.4. Will somebody be so nice as to Pythagoras theorem the speed for me? Oh, you already square root it and everything. 25.3, 2, and we're done.